Hello everyone, my name is Anvita Bansal and we are back with another lecture today on hash maps. So the problem for today is find all four sum numbers. Let's have a look at the problem. So this is your problem for today from SDE Sheet. So this is a very nice problem, quite frequently asked in good companies interviews. And let's have a look at this problem. Let me check if you guys are able to see me before that. Okay, that's fine. Fine. So the question says that you are given an array of integers and another number k. Find all unique quadruples from the given array that sums up to k. Also, the quadruplets should be returned in such a way that for any quadruple q1, q2, q3, q4 they should be in sorted order, in the ascending order. That's what you are saying. So the question says that here is an array. You need to find such four numbers whose sum is equal to k. There can be any such quadruples. This is one such quadruple. There can be another such quadruple. So you have to return each quadruple in the sorted order. So let's understand this problem. Let me take this test case itself, 0, 0, 2, 1, 1. Okay. So let's have a look. 0, 0, 2, 1, 1. So this is the given array, let's say, and your k is 3. So first important thing here is to understand the problem itself. I'm sure you must have understood that already, but let's have a look at the conditions they are telling. So the first thing that we have to check in this problem is four numbers whose sum is equal to k, right? First thing. Then there can be any such quadruples. These quadruples, each quadruple should be in sorted order. That you return must be sorted. That means they should be in ascending order, whatever you return. Okay. Now the third thing is that there can be more than one such quadruple which is giving you sum is 3 and those quadruple have same elements, right? So duplicates of quadruples might happen which you want to get rid of while you return. So I'll explain this point. No duplicate quadruple. That is what you want to ensure in this problem. Quadruple. Okay. So let's understand each one of them one by one. So the first thing is, this is your array, okay, and you want to find four numbers whose sum is 3 and there can be as many quadruples possible. Okay, so in this problem you can find 3 by using, this is at 0th index, this is first index, second, third and fourth. So these are the index that I have written. Okay, now if I take the element at index 0, if I take 0, then I will need to have a sum of 2 from the remaining array so that I need to find a sum of 3 from the remaining array so that my total sum becomes 3. So I do not have that exact 3, but I can have more such numbers which can give me a sum of 3, right? So here you need 4 such numbers. Let's say if I take 0 from here, I take 2 from there, I take 1 from here. What is the sum I am getting? This is equal to 3. But are these 4 elements which are giving me sum of 3? No. So this is not a quadruple. So what you need to find is 4 such numbers. So let's have a look. What if I take 0, then I take 1, I take another 1, right? And then can I take any other element from this array? No, I cannot. I want a sum of 3, right? So I don't think so taking 2 ones is going to help me. Now let's have a look at what can be the correct solution to this problem. So if I take 0, if I take another 0, then I take 2, then I take 1. Can this be your answer? Yes. And if you go and check for all such quadruples in this array, you will see that you will get only one answer. Only one answer. And the answer that you want to return is, it should be in, first thing we found is 4 numbers whose sum is k. So we found one solution from this problem. Second condition we want to ensure is that what you return, it should be in sorted order. So if I want this to be in sorted order, I would want to return it in the form of an array list which contains these values, these elements in this order, right? So this is what I want to return. Okay, fine. Now in this problem we had only one such solution possible. Let me just twist this test case and let me bring forth some other example which will help you understand. Let's say if your given test case was 0 0 2 1 1 3, let's say. Okay, so 3, fine. Let's say this is your example, and again you want to find a sum of 3. Fine. What can I take is, I can take this 0, let me include this 0, this is 1 0, let me include this 0, this is 1 0, then let me include this 2, okay, then let me include this 1. So I can get one quadruple from here. Another possible quadruple can be, I take both the zeros, these zeros, same, okay, 0 0. I take this 2, but I take this one now in this example, okay. So this is also one quadruple. You see that I have not repeated the same index element, but whatever quadruple I get, that is exactly the duplicate of what I found above, right? So how can you ensure that your quadruples are not duplicated, right? No matter, the one that I took in this case was not this one. In my second answer I took this one, whereas in my first quadruple I took this one. So both the ones according to this array are different, but eventually they form a quadruple which are exactly same, right? So how will you ensure this thing? This is one thing that you need to ensure. Now let's come on each thing one by one. In order to ensure that each quadruple is in sorted order, one thing we can do for sure is, let's assume that we are filling up our answer in an array list that we want to return. So why an array list of list? Before that, let's move to the problem statement and see how they want you to return. So basically what they want you to return is, return a list of array list, an array list of array list, such that if let's say you have 3 such quadruples, so that should be part of a list only, and each element of a quadruple itself is a part of a list. That is why you are returning a 2D array. You can understand it in that way. One second. Fine. So moving back to the, this was the problem, right? Okay, moving back to the problem, how will you ensure that your quadruples are in sorted order? So one thing that you can do is sort your array, sort your given array, so that whatever array we have, we will be iterating over the array in the sorted order. Whatever element we will be adding into our final answer, at least this thing will be ensured that each element that we are adding must be greater or equal to its previous element. It cannot be smaller. So one thing you can do for this is sort your array. Now second thing is, how will you solve this problem? Now let's understand this thing. This is important thing to understand. How will you solve this problem? 2 1 1 3. So if you guys have already gone through 3-sum problem, then you will realize that it is almost similar to that problem. If you have understood its approach, this one is going to be easier for you all. And then towards the end, I'll be discussing about hash map approach as well, but we won't be solving using the hash map approach, as its time complexity will be more than what we are going to discuss now. It wouldn't be more efficient. Let's have a look. So what I'm trying to say here is that you have an array and let's sort it already. So when I sort it, it looks 0 0 0 1 1 2 and 3. Okay, fine. Now what you want to do is, let's take 2 loops, okay, and for each loop we will find what are the elements and we will calculate the sum. It's almost like what is present at ARR of I, what is present at ARR of j. Now we will be checking for the remaining 2 elements and we will be checking all together the sum. If that is equal to k, then we will do something. If not, then we will take the actions accordingly. Okay, so let's check for I. Let's say it will start from 0th index and let's make it go till this index, or you can, for now, if you do not want to keep a track, let's make it go till n I plus plus. Okay, then within this we are running another loop for j starting from I plus 1. Okay, j again less than length of your array, j plus plus. What you want to ensure is that whatever element you are choosing, let's say your I is at this position, your j is at this position when you start with it. So what is the sum that you get? You get 0, you get 0, another is you get another 0. Now you want to know what are the other two elements and how will you iterate over them so that you get a sum of 3. So what I am doing is I am going to define two variables again, one let's say left, that will be at j plus 1th index, and other one let's say right, which will be at your n minus 1th index, right? Let's take them. Now why I have taken these two pointers, this is what where I'm making use of two pointers. I could have simply starting with the brute force approach, in which we are taking four loops I, j, k, l, let's say, right? For each loop I am checking always the sum of all these elements. L goes here, then I check the sum of these and this, then L goes here, check the sum of this and this. As and when I get the sum equal to 3, I add arr I, j, k and L into my array list, right? And then add to that final array list. Same thing, basically that will be a task of 4 loops, right? So complexity of O(n) to the power 4 will be the time complexity, right? That's the very brute force approach. But I am trying to optimize that approach using a two pointers theory here. How two pointers are going to help me? So what I'm doing is I am going in the conventional way, starting my loop at from I at this index, j at I plus 1th index. Then what I'm doing is I am taking a left pointer which is at wait. This is your array over which I want to iterate. And side by side I'll be just writing a pseudo code for you to understand that what are we doing. Okay, let's put it here. Fine. So what I'm doing is initially my I is at 0, my j is at I plus 1. I take a left pointer starting from j and right pointer at the end of my array, right? Then I calculate what is arr of I. Tell me what is arr of I plus arr of j plus arr of L plus arr of R. Is that equal to S, right? If that is equal to sum, required sum, that is k here is 3. I will check what is the sum. If it is equal to 3, then what you want to do, we want to store it into our answer array. If not, if sum is, now let's write it here. So how will I write it? I will take a loop while. So tell me one thing, as in when I'm iterating over this array using these two pointers, these two pointers can only go until L exceeds the index of R or R precedes the index of left, right? So while L is less than R, what you are trying to check? You are checking first, let's say your current sum, C sum, is equals to ARR of I plus ARR of J plus ARR of L plus ARR of right? This is what your sum will be. So if this C sum is exactly equal to K, the sum that we want, then what you are going to do? See, you are going to add this into your answer. Any array list, let's say you have made an answer list, answer dot add all of these values one by one. First ARR of I, then J, then K. So 4 times you will be adding this, and then you will finally add this to your result. Let's say result dot add ANS. Now what? You have got one quadruple for sure. Now what? Just increment the count of your left pointer and decrement the count of your right pointer, right? Now let's have a dry run. Let's have a look at this till now what we have discussed. So this is 0, this is 0, this is 0, this is 3. Is it equal to 3? Yes, it is. So this is one quadruple that we have found, and that can be added to our final answer. So this is 0, 0, 3, right? Fine. Let's say this is a quadruple. and now my left pointer will be moved from here to here, right? My left will be, and since I got this as answer, so right will also be moved from here to here. Now what? Now check the sum. 0 0 1 2. So this is also one quadruple, 0 0 1 2, which I will be adding to my answer. Fine. And just make sure one thing, till now we are not checking if I am dealing with the duplicates or not, right? You getting this point? You will understand when we just come across that example, but for now you have not put any check to ensure whether you are taking duplicate elements or not. Let's see, when that case will come, we will deal it. Okay, now again you got your answer, so L will be moved one step ahead. One second. Okay, so let's move L here, and R will be here. R will also be moved to the, it will be decremented. It's now both are at same position. When both are at same position, that means you come out of the loop. Now your iteration goes back to J. When your J was at I plus 1th index, now increment the count of J. So your J will now come here. Again, going to this line of code, L becomes J plus 1. So L will come back to this position. L will come back to this position, and R will come back to the n minus 1th position, right? That's what we are doing when we are running a jth loop. Okay, now what is the situation? You have 0 0 1 3. So this sum, now tell me, currently your sum, what you see is your sum is 4 right now. C sum is 4, and you know this 4 is greater than 3. So in order to get sum which might be equal to 3, obviously since this is a sorted array, you know this thing for sure, that you need to find an element which is towards the left of 3, because including 3, if we are at these positions 0 0 1 and 3, if I see the sum is greater than the required sum, so I need to shrink an element's size so that I can get a sum which is equal to 3. For that, one possible thing that I can do is just decrement the count of index right. If I move my right index to the one step left, that is I decrement the index of my right pointer, maybe I can get a sum which is equal to 3, because one thing is for sure, if my sum is greater than the required sum, I am not going to get any sum beyond that element, right? So I can get a sum which is towards the left of that element. So that is why I move right to the left pointer, one index before. So for handling that case, I will be writing if so this was the case, if sum was equal to your k, exactly equal to. What if, else if sum is greater than k, your current sum, this is your C sum, then what you are doing, you are decrementing the count of right pointer. And in else case, if let's say my current sum was 2, for example, then one thing is for sure, that if you move left pointer to the left side, that is you decrement the count of left, you are not going to get a sum equal to 3, because all the elements towards the left of left pointer are either going to be equal to it or less than it. So one thing is for sure, you need to increment the count of left pointer in the else case, increment L plus plus. Okay, so this is how you are handling the sum thing, right? Okay, fine. So when I came at this position, let's check the sum. It is 0 0 1 2. Let me add it, 0 0 1 2. But do you see one thing? These both are duplicates here. I have got duplicates, and I have not handled this case so far in my pseudocode. So how do we handle this case? So one thing that you need to ensure is, whenever you are moving your left pointer or your right pointer, ensure one thing, since we are always incrementing left by one position and decrementing right by one position only, so just ensure from whichever position you came to one step ahead. Okay, let me move it to the one step back. When my L is at this position, R is at this position, let R be at this, J was at this position, L was at which position, right was it, let me check, when I got 0 0 1 2, so this was 0 0, L was at this position and right was at this position. Okay, let's come back to this position and understand. Now what I found was, I found that my C sum is equal to exactly the sum that I want, right? And I have put this into my answer. Then I increment the count of left and decrement the index right by 1. When I do so, I have to always keep a check. Okay, when I'm doing so, when I'm moving for left and right pointers, is the next one exactly equal to the previous value? If that is the case, then just don't do that. That is what I want, because that will avoid duplicacy. If I move my left to this pointer, again I'm going to get 1, which will make no difference. This will be 0 0 1 2. So we do not want that. So what you're going to put a check is, while your ARR of left pointer is equal to ARR of left minus 1. What you do is simply increment the count of left. We do not want. You will keep incrementing the count of left until you get a left pointer which is different from the previous value. We have already included 0 0 1 2. Again I have got 1, so I am going to get the same pair if I keep right pointer at this position. So I will move it until I get a different index value. Just forget about right as of now. I'm just explaining how you can avoid the duplicacy. Now same goes with your right pointer. Whenever you are moving for your right pointer, you will check while ARR of right, since right is going by as R minus minus, you are decrementing the count of right, so you have to check if ARR of R is equal to ARR of R plus 1, right? When you do that, you have to check it and then you decrement the count of R minus minus until you get a different element. Now does one thing strike to you? You have to check for the same thing when you are making a move on your I and J pointers as well. This 0 0 and this 1 2 has been added into one pair. Okay, let's understand it this way. I take this 0 of I, this 0 of J, this 1 and this 2. When I move my increment my I, let's say my I is at this position now, so and J will be at this position, so 0 0 1, let's say, and 2 again will give me the same pair. So this thing has to be ensured for I and J as well. Okay, so I will put a check for I. When I'm running the loop of I will put the similar check. That will be while, or you can do it in this way also, if your ARR of I is equal to ARR of I minus 1. If the next index value is equal to the previous index value, then what you want to do, you do not have to do anything, just continue, because you are already running a loop. You make a continue, with continue again come back to the first line of your loop, right? So I will be automatically incremented. Same thing you need to do for J. Also you have to ensure one thing, when my I is at 0, and you check for this condition, ARR of I is equal to ARR of I minus 1. So I minus 1 will be minus 1 in that case, and your array's index will be out of bounds. So you have to keep a check that if ARR of I is not equal to 0, that is when your I is 1 or greater than 1, only in those cases you will check, and then you check for the further things, that ARR of I is equal to ARR of I minus 1, then you do continue. And same check you will do for J, that your J always starts from I plus 1th index. That is, the first case would be when it starts from first index. So whenever your J is at 1 index, you do not want to execute this if condition, right? So you will check if your J is not equal to I plus 1 or I plus 1. That's what we want. And basically whatever position you are, J starts from I plus 1, so that thing you are always going to include. So if your ARR of J is not equal to I plus 1, that is what you can do. And then you go ahead and check ARR of J is equal to ARR of J minus 1, continue, right? I hope this thing is clear to you all now. Let's try and code it, and then we will come back and check if you guys are able to execute this this entire dry run or not on your own. Let me have a look if you guys are able to see my screen. We can write it as L less than or equal to R also. Fine. Okay. So let's move to the code now. Just a second. Fine. So first thing is that I am sorting my array. Okay. Arrays dot sort ARR. Now what? Now you take an array list of array list that will be of type integer. Answer, let's say, equal to array list. Fine. So this is what we have done. Now let's start with the loop. For int I equal to 0, I is less than n, I plus plus. Okay. For int j equal to I plus 1 always, j less than n, j plus plus. I am taking 2 pointers, int left starting with j plus 1, int right starting with n minus 1, right? Where my left pointer should be less than my right pointer, or it can be equal to also. No, important thing, since you asked, it cannot be equal to right pointer because we do not want duplicate values. This is the reason, right? Let's say you are at 0 0 and then you come at maybe 3. Okay, so your left is also at 3, your right is also at 3. So what your array will do, your logic will add 3 twice. So we want to avoid it. In order to avoid it, it cannot be less than or equal to, it should be always less than, right? Left and R indexes cannot be at the same position at the same time because it will bring the duplicacy of elements. Okay, I will check. Int current sum, let's make it C sum equal to ARR of I plus ARR of j plus ARR of left plus ARR of right. Okay, if C sum is equal to target is k here, then what you are doing, first you are making an array list in which you can add all these 4 elements. Array list of integer ARR, let's say, not ARR, temp, new array list, in which you can add arrays dot as list. And what do you want to add? ARR of I, ARR of j, ARR of L, ARR of right, R, right? These are the elements that you would want to add. I have written it arrays dot as list because in an array list you are adding the array value or elements of an array. So in order to make this elements of arrays get into array list, we use arrays dot as list, or you could have simply done it this way: temp equal to new array list of type integer, then one by one temp dot add ARR of I, temp dot add ARR of j, and so on. So this is just a shorthand method I've used here. Okay, then finally you also add it to your result answer array, answer the bigger array, right? You want this quadruple like this here to be added to your final list of list. So answer dot add temp, and then you move for the next answers by incrementing the count of left and decrementing the count of right by 1. Okay, next thing, if your C sum is greater than target, it's greater than your k, that means you are going to find a sum equal to k before right index, so R minus minus, and in the else case L plus plus. Fine. Now to avoid duplicacy, where will you put that condition which I showed you here? This condition that while your left value element in the array is equal to the previous value, you want to avoid that and you will move ahead. So let's see when you can do this thing. Okay, so let's make a check here, we can do keep a check here. Whenever we are incrementing the count of left, let me put it, just a second. Okay, so this is your if, this is your else. What happens is, this is your while loop which is handling your left and right pointers. So these are three conditions. If c sum equal to k less than k and greater than k, then you are doing some operations on left and right. So after doing those operations, you will check now whatever position your left pointer is, if ARR of that left is equal to ARR of left minus 1, right, then you do L plus plus. And wherever your right is, while your ARR of right, wherever your right pointer is, you have to check that element with the previous element from where you have moved your right pointer, that will be ARR of R plus 1. So if that is the case, both are equal, then you do R minus minus, that keep decrementing my right until and unless left and right do not cross each other, right? So this is the check that you have put here. Fine. Okay, now what you come out of this for while loop, this is left while loop, this is your jth while loop, this is your ith while loop. Finally what you would want to return is answer. And before I operate on further, this is it. But since I told you we want to check for duplicacy even when we are iterating with the I pointer and the j pointer, so for that the first element that I is going to start with is always I. So if your I is not equal, that we always want to include if that comes into answer, there we do not want to put a check. And your ARR of I is equal to ARR of I minus 1, then continue. Same thing for j, if your j is equal to I plus 1, right? If your j starts from I plus 1, that means that is a starting point for j. You do not want to compare it with what was present before, just before j. That is why we have put this condition. And ARR of j is equal to ARR of j minus 1. Again what you do is continue. Fine. And then you take 2 pointers. Let's check. (51). Have I declared it in the wrong way? Oh, new keyword is missing. Shit. I need to define what is n. N is the length of array. Answer dot add temp. I think it is not adding it. Temp dot add ARR of I, temp dot add ARR of j, temp dot add ARR of L, temp dot add ARR of right, then answer dot add temp. Why is it giving me -1? Arrays, array list of list. Should have worked it that way only. While left pointer is less than your right pointer, IJLR csum equals to k new array list. Temp dot add, 1 second, temp dot add, here are I, J, L and R, then answer is adding that final L plus plus. Do you see any mistake here? Then write it in the chat. Meanwhile I am checking why is it giving me this error. Let's check. This should be fine only actually. This seems okay. What can be the mistake? IJLR. Let me write it in that way only, shorthand. Arrays dot what can be the answer? R. Each time it will give me some error only. Now what is the issue? The temp new, it is fine only. It's not able to add it. If else, then we are trying to okay, I think there is some logical error. Let me check now. What is the issue with this? Else if csum is greater than k, r minus minus, else l plus plus, j is equals to shouldn't be equal to I plus 1. Let's check it now. Also, while left is less than r and while left is less than r, I will also explain what was the issue. First let's see if it passes or not. Okay. So look here, what mistake was there? First of all, since that was just an error, I was explaining you that j when it starts from I plus 1, that case should not be considered when we are considering this condition. So that was one mistake that I did here. I explained it fine, but I made a typo here. But there was one logical error that was done in this code, which was we were checking for this condition after this, means after we were executing all of these cases. But point to understand here is we always are checking for this condition for duplicates when we are adding some answer to our final array list. So when your csum is equal to k, that is when you are adding some answer to your final answer array, right? In that only you are doing L plus plus and R minus minus. But when you have already added an answer, that is when you want to check if you are going to come across some duplicates. So you put a check here, and I had put this check here, which was not correct. The check should be kept here, not here, because in other cases we are not already adding. So what do we have to be worried about? This is the reason. So coming on to time complexity, before that, if you guys have any doubt in this code so far, you can ask me in the chats. Yeah, it was just a little logical error which was done in that code. That was why it was giving me that error. Can and think there are no more new doubts. If you have, you can ask me. Okay. So coming back to this problem, let's have a look at what is the time complexity. Let me take this code. Let me take this code. Okay. So what I want to explain you here is let it be. First thing, we started off like this with a loop for I, another loop for j, which is typically starting from, where's my pen? A loop starts from of I starts from the first index, right? Okay. Then j typically starts from I plus 1, which covers the rest of the elements. So we can take this so far as O n square, right? Then we use a while loop of left and right, where left typically starts from j plus 1 and right starts from the last index, and they almost cover the remaining elements each by half. In the worst case scenario, it will be like right will be traversing all towards left index or left and vice versa. So we may take this to be another loop of typically n. So it will altogether be of O n cube of time complexity. Do you see any other loop in your question be happening? Then there is this loop. This loop is nothing but just a loop for check, which can be consumed within this n loop time complexity which we are doing, because this is conditional loop, right? This is the conditional loop, and the maximum it will take will be the length of as many times you will find a duplicate. In worst case scenario, duplicates will be all over the array, but that has been already included in this on of time complexity. So, and another thing is, do you take any extra space? Are you taking any extra space here for the answers, for the manipulation of the code, or for the logical reasoning of your code? No, we are not taking any extra space for our answer, right? We are only taking an extra array list in which we want to return the answer, which is the need of the problem. So there is no extra space. So maximum of O n cube is the time complexity in which you are solving this problem. I hope this much is clear to you all. If you have any doubts, you can ask me in the chat. And this is a very good problem. This is something which is not an which might not immediately come, its logic or its intuition might not immediately come to your mind. So the very brute force approach is using those four loops of n4, which will take O n4 of time n to the power 4 time complexity. We optimized it using this approach, in which we are taking help of two pointers which reduce the time complexity to O of n cube, right? Then there is another one using a hash map, which I was talking about, but I see that the lecture will go beyond the time. but I will introduce that logic to you. So we are keeping a hash map. Just quickly, I'll not go into details. We can take this in some other lecture. So what happens is we are keeping a track of all the pairs sum into your hash map. By that, what do I mean? You check how many pairs will be there in your array. If I see this array, one will be 0 0, another pair will be 0 2, another pair will be 0 1, 0 1, right? This is all the pair with 0 as your first element. Then with this 0 as another element, you will have 0 2 0 1 0 1. Then with 2 you will have 2 1 2 1. With 1 you have 1 1. So these are the total number of pairs that you will have. In hash map, what you will store is, you will store the sum as key and these pairs as your values. So what is the sum? The sum of these this pair is 0. So corresponding to that, I am adding an array list, okay, which will contain an array list, maybe, or maybe you can take a hash map of pair type. You can define a pair class and its corresponding constructor, which will have this and this as first and second elements. So this will have 0 0. Then what is the sum? You will check in your hash map, is sum 2 already present? No. So corresponding to 2, you add this pair, you add this 0 2 pair. Then what is the sum? It is 1. So corresponding to that, you add this pair, and then you have this same value, same pair, and corresponding to that, you already have that sum. So you add that to your hash map. Another important point to note is that you are not exactly adding the elements value, you are adding the indices. Here I am showing you value, but you will be adding indices. So this is how you will take your map. Okay, I'm not going through everything. How then you iterate to your loop, you check at every step. It will be a O(n) square of loop where you will be checking. Let's say this is 0, this is 0 0 0. Now this is a sum 0. What is the target sum? 3. So there must be some sum already. So you will check 3 minus 0 is 3. You will check, does your hash map contain a pair of sum 3? So if it says yes, you will add to your answer. You have to manipulate it. Lot of things goes into this code. Same, then you go ahead and check for every n square pair of loop. You are going and checking, does that pair exist for that particular sum in my hash map? If so, you add it to your answer array. So the problem with this code is, in worst case, the time complexity can go to O of n to the power 4. The reason is, also in the previous problem, the total time complexity is log n cube of log n. Why log n? We have to consider the time taken for the sorting. So that took some n log n of time complexity. Wait, n log n plus n cube is the total time complexity. So you can ignore this and make it O of n cube, right? And for the hash map, the worst case scenario, in average case it will be O(n) square, but in worst case, time complexity can be n to the power 4, because in hash map you will also have to iterate over that hash map pairs. Let's say this is pair 1, this is pair 2, this is pair 3. Let's say you have total 4 pairs, and that is the entire length you are iterating of an array. Let's say arrays of length 8, and you have 4 pairs, so totally you will be iterating over each pair. So in such a case, when you will be going through hash map every key and iterate over its pair, so worst case can make you reach to n to the power 4. So this is some, I know you might have not very well understood, but I just introduced this method so that you can try it on your own. You will be taking a hash map, which will not be of normal type int comma int. It won't be of that type. It will be of type pair comma integer. Pair is some pair class that you will be defining for yourself, so that you can include that indexes of 2 such elements in your array whose sum. So what will happen is, pair will have 2 elements, so element indexes. So ARR of element 1 plus ARR of, let's say, pair 2 element 2 whatsoever element 2. Then whatever you are iterating over via ARR of I and ARR of j. So what you are doing is, you are splitting into half. You are checking if ARR of I plus ARR of j, this sum has to be, your total sum is, let's say, k minus ARR of I plus ARR of j Does this value exists in your map? If so, then you will add that pair to your answer and return that to your final array list. That's how you would like to manipulate it. So if you have any doubts, you can ask me. This is the so far this is the best optimization we have found for this problem, because in hash map also, even though average time complexity is reduced, means it's not n cube, it is less than n cube average time complexity, but the problem is you are taking space, extra space of that hash map. So, and already you are sorting also, other steps will be same, but you are doing these things extra. So I wouldn't say that is much efficient, the hash map approach, and it's not very intuitive also, although you can try it on your own. But the one that mostly you can prefer to do is this problem. This is because in if you have solved threesome problem also, you might have solved it in this way, so this is quite likely to come to your mind. And yeah, so that is all about this problem for today. I think if you have no more doubts, you can wrap the lecture. Fine, everyone, then let's wrap this up and see you all in the next lecture tomorrow. Thank you, everyone. Bye bye. Take care.